let's go through Leak 1061, lexicographically smallest equivalent string. So it gives us S1 and S2. So we'll say S1 and S2, they have the same length. And for the index, for example, this I to, if the length is n, right, to n minus 1. So for each character, um, they can be in these two strings. For example, there is a character S1I and S2I. Those characters can be reflective, that is, can either be equal or symmetric. For example, if there is an A and B, they appear in the same index, then that it has B equals to A as well. And transitive, that is A equals B, B equals to C, then that means A equals to C. And we give a base string and from this base string, we are looking for the lexically smallest equivalent string. So let's look at the example S1 and example 1. You'll see S1 has Parker, S2 has Morris, and the base is parser. And the lexical smallest result is MAKKET. So because what we do is we compare P and M, this belong to the same group, and also AO belong to the same group. And we also find, for example, R, this K and R belong to the same group. So you see R and S on the last belong to the same group. That means K, R, S, R belong to the same group. And also E and I belong to the same group. Then based on the base string, we transfer it to lexically smallest. So for this question is that we do union find, but the thing is that for the union option, right? So for the union find, that is for every character, if they are in the same index from string S1 and S2, right? We're able to union them, right? So for example, we have this kind of A and O, we're able to union it. And also this R and K, we are able to union, right? And also S, we are able to union. So we have KRS are in the same group. And for KRS, right? So every time, what we want is that we just get we can get the smallest, lexically smallest character as its parents. So when we translate this base string to its parents, just use the for every character to find that it's the root parent. Then I convert this string to the string that will be the lexically smallest. So let's write code for this. So we need a class union find, right? And for this union find, we know it is a 26 character. So we have a array, right? So public union find. We don't need passing the integer because we know this is 26 character. So just let this one to be new 26, right? So initially we should for int I equals to 0, I smaller than 26, I plus plus. So we're going to have further I equals I, right? And for the union function, public void union int A, int B. So we're trying to find their parents, right? So we'll say int FA underscore equals find A, and int FA underscore B equals find B, right? So the thing is that here, we'll say FA and FB, that if they equals, we don't need to do anything, right? So only when it doesn't equal, we need to set one of the either FA's father to be FB FB or FB is father to FA, right? So we can always set the father to be lexical smallest so that when we use the find function, it will always be the top parent, the root parent will always be the smallest. So what we do is that, well, right, if FA underscore A is smaller than FA uh, underscore B, we'll set father FA score B equals FA score A, right? And else we set further FA score underscore A equals FA underscore B, right? So this is a union function. The find function is still the same. We do recursive call to decrease the path length, right? So we'll say if x equals further x just return x, then we'll have father x equals find father x, and just return father x, right? So now what we do is that we just go through these two characters, go through um, the character by character and the try to union them, right? So we'll have char array one equals s1 to char array, and array two equals s2 to char array. So then we're going to have unified class equals new union find. Then we can do for int I equals 0, I smaller than array 1 dot length I plus plus, right? So we're going to have UF dot union. So that will be array 1 I minus A, right? And array 2 I minus A, right? Minus these two indexes. And in the end, we from the base, right? We just use a find function that will be the lexical the smallest is in its group. So what we do is that um, we're going to have a string. Um, we can have this, right? Char array equals base string switch array. So what we do is that for int I equals to 0, I smaller than array dot length I plus plus. So we're going to have array I equals union find this array I minus A, right? This is integer, right? So we need to have change this as char this one plus A, right? And in the end, just return new string array. So we'll say the time complexity. Well, if this is n, this is m, right? So that's why m plus n, right? In the space, we use these char arrays. We can, if we just iterate this character by character, we can consider that coincidence, constant. But here we can also say that is m plus n, doesn't matter. Um, and this one is 26, right? And let's also write Python code for this. Um, So so we know for this we need a union find help class union find, and we need a um so so what we do is that we have self that let's say parent, which is a list of int equals list of range 26, and we need to define the find method, right? Let's define the union method first. Union self dot a, which is an int, and b, which is also an int, right? And this one is none. So what we do is that we'll say PB equals self dot find A and self dot find B, right? So if PA equals then we just need to return, right? If this is smaller than PB, then we'll have self dot parent um, PB equals PA, right? And let's say else if PA is greater than PB, right? Then we'll have self the parent PA equals PB, right? So we'll always have the lexically smallest, smaller to the parent, and also def union find, right? Find self x, which is an int. Let's this one should return an int, right? So we'll have if self dot parent x done equal to x, right? We'll have self dot parent x equals self dot find self dot parent x. So we just return self dot parent x, right? So this is a union function, union find, right? So now, mm, let's write our function here. We need a let's new union find, right? Help class. So for C1, C2 in zip S1, S2, right? So we're going to union then. So UF dot union ORD C1 minus ORD A, right? And also ORD C2 minus ORD A. So after this union, right? So what do we do is that our result will be a list, result char will be a list that is a list. We use a char function, char function, and UF dot find ORD uh, ORD C minus ORD A um let's see And actually, this one we need to add ORD here, right? So for C in base string. So what we need is return this one dot join result.